to discounting cash flows using a spreadsheet, and this would be a simple example. Discounting cash flows always uses 4 specific variables. What we're trying to solve for is called present, let me see if I can type that, present value, and which we will label PV. That's what we're always trying to solve. What is money worth today? The other 3 variables that we use in discounting cash flows are called future value, and usually we know what that is when we're trying to solve a discounting cash flows problem in a spreadsheet. And essentially, in simple terms, discounting cash flows allows us to know what something is worth today when we know what it's going to be worth in the future. This is super relevant for, well, it's the fundamental skill of valuing stocks and bonds. It's also relevant for understanding something like the value of an annuity or a future pension payout or government obligations due in the future like Social Security or Medicaid obligations. It's anytime we know what something's worth in the future, but we'd like to know, well, how much is that really worth in today's terms? So we start with the future value. We also generally have a term that I'll call the discount rate, but the discount rate goes by many names. It could also be called yield or interest rate or IRR. So I'm just going to write that here as a reminder. IRR, it could be called a growth rate. Expand that. Those are just different terms for a discount rate. And then finally, we generally have a variable for time. In the simplest case, which we'll do with this example, we'll talk about years, but it could be other time periods. Now those 4 variables are put together to create the discounting cash flows formula in the following way. PV is equal to FV, so present value is equal to future value divided by 1 plus the yield term, and that bottom number, 1 plus yield, is raised to the power of n. Now, if you've done compound interest formula before, and I'm guessing you have, you'll notice that the exact same 4 variables are used in the discounting cash flows formula as in the compound interest formula. The difference is we are solving for a different variable. We are solving for present value. In the compound interest formula, we're solving for future value, and algebraically we could see it if you multiplied both sides by the 1 plus y raised to the power of n, you would get the compound interest formula. But in this case, we're going to do discounting cash flows, and we're going to do an example. So here's my example. Let's say you are trying to quit your job, but the boss says, no, don't quit your job. I want to pay you a big bonus 5 years from now if I can keep you for the next 5 years. Well, how much is the big bonus? Well, we'll say the big bonus is going to be $50,000. Trying to keep you for 5 years. So the big bonus in the future, 5 years from now, is called the future value. Well, you think, well, $50,000, that's quite a lot. I would like that. But what is it really worth today so that I can figure out should I keep my job or not and stick around for that? So $50,000 is future value. The n, the time, we've already said it's going to be 5 years from now. And here's the tricky thing, which will take a little bit of art plus science to figure out what the proper discount rate or yield should be, which I'll call the y term. But for now, let's say that this is a small company. It's rather risky in the fact that the company's going to be around in 5 years is not absolutely certain. That's why the boss wants to keep you as the key employee. Let's say we'll call that a 15% discount rate on that future bonus payment. And finally, we want to plug in what is that worth today, which technically we'll call present value. That's what we're solving for with the discounted cash flows. So I'm just going to build this formula just as it's written here in cell A7. So to signal to Excel, we're going to do a formula. We start with the equal sign, equals. Then if I'm following the menu here, it says FV, so that's this one. I click on that button, FV, divided by, open parentheses, 1 plus the yield term, that's this one, D9, end parentheses, raise to the power of the little caret, shift 6, raise to the power of n. Now I've completely programmed this in to cell D10, and it spits out an answer. Now I'm going to change that over to a currency by clicking this little button. Boom. So $50,000 to be paid 5 years from now, in today's terms, is actually worth $24,858.84. There's a couple of other things we could say about this. One is I haven't explained why the discount rate is 15%. And I would say that would be the case if this is a risky payment or not likely payment, would be maybe a 15%. Now if we instead shifted the example, and this is sort of, now we're going to get to the point of why do you put this into a spreadsheet? And the point is I want to be able to change these variables very quickly and see an answer very quickly. So let's say it's not a $50,000 bonus from my boss to retain me, but rather it's a $50,000 contract that's super safe from the government. In that case, we wouldn't discount it at 15%. We'd say, well, super safe, it's a guaranteed thing. I just have to comply with the contract. I'm going to say, well, maybe it's just a 5% discount rate. A lower discount rate essentially means it's not risky. So I'm going to change 5%. Well, actually, let me go out here. Let's change it to not risky and likely. And I'll change this then to 5%. Boom. The $50,000 in the future is worth $39,000. The next thing we can see when we have programmed in this kind of formula into our spreadsheet is say, well, it's not actually $50,000. I managed to negotiate it to $65,000. That contract with the government. It's not $65, $65,000. There we are. $65,000 paid by the government in a not risky situation worth $50,929. Well, what if my retention bonus, going back to that, is actually if I can stick around for 10 years and it's not quite as risky as I thought because of certain things I learned? Well, maybe that's just a 12% discount rate. Boom. $65,000 10 years from now might be worth $20,928.26. The point of putting it into a spreadsheet is that you can change any of these variables and quickly get an answer. I hope this is a good introduction to how to figure out how to use discounting cash flows, and we'll get a little complex in the next video.